Hello everyone and welcome to this video on constants in Python. Have you ever wondered how to define values in your code that should remain unchanged throughout the program? In this video, we'll explore what constants are, how to define them, and why they're essential for writing clean, maintainable code. We'll also look at best practices, tools for stricter constant management, and practical examples to help you implement them in your projects. Let's dive in. Introduction. A constant is a variable whose value should remain unchanged during a program's execution. While Python does not have built-in support for constants, developers use naming conventions to define them. Constants are typically written in uppercase letters, often with underscores to separate words such as pi 3.14159 or max underscore limit 100. These naming conventions signal that the value is meant to stay constant even though Python does not enforce this immutability. Constants are useful for storing fixed values like configuration settings, mathematical constants, or system-wide parameters. By treating such variables as unchangeable, you maintain cleaner, more predictable code, following Python's emphasis on readability and good coding practices. Defining constants in Python. In Python, constants are defined using a simple and widely accepted naming convention by assigning values to variables written in uppercase letters. For instance, variables like pi 3.14159 or gravity 9.8 are clear examples of constants. The use of uppercase makes it immediately recognizable that these values are meant to remain unchanged throughout the program. While Python does not enforce immutability of constants like some other programming languages, this convention relies on developer discipline. It serves as a visual indicator to anyone reading or working on the code that these variables represent fixed values and should not be modified. Constants are often used to store essential and unchanging values such as mathematical constants, physical constants, or application-wide settings. Adopting this practice improves code readability and helps in maintaining consistency, making your programs easier to understand and debug. Using constants in code. Constants play an essential role in making your code more readable and maintainable. For instance, consider calculating the area of a circle using the mathematical constant pi. Instead of hardcoding the value of pi directly into the formula, you define it as a constant like pi 3.14159. This not only makes the code more readable but also ensures that the value can be updated easily if needed in the future. Here's an example. You define pi as a constant, set the radius of the circle to 5, and use the formula area pi radius 2 to calculate the area of the circle. Finally, you use the print function to display the result. This approach makes the code intuitive to read and understand. By using constants like pi, your code becomes self-explanatory as anyone reading it can immediately recognize the purpose of the variable without needing additional comments. This practice also aligns with Python's philosophy of prioritizing readability and clarity in programming. Best practices for constants. When working with constants in Python, following best practices ensures your code remains clean, consistent, and easy to maintain. The first and most important rule is to use uppercase names for constants with underscores to separate words for better readability. For example, constants like max underscore users 100 or API underscore key 12345 ABCD clearly indicate their purpose and signify that their values should not be modified. It's also a good practice to define constants at the beginning of your code. This makes them easy to locate and manage if changes are required in the future. For larger projects, consider storing all constants in a separate configuration file or module. This keeps your main code uncluttered and allows for centralized management of constant values, improving scalability. Finally, avoid changing the value of constants during program execution. While Python does not enforce immutability, Treating constants as unchangeable helps maintain the integrity and predictability of your code. By adhering to these practices, you enhance your code's readability, ensure consistency, and make it easier for others to collaborate on or review your work. Using constants in external modules. To maintain clean and organized code, it is often a good idea to define constants in a separate file and import them wherever needed. This approach is particularly useful in larger projects where constants are used across multiple modules. By centralizing constants in one file, you can easily manage and update their values without altering the main logic of your program. For example, you can create a file named constants.py and define your constants there, such as pi 3.14159 and speed underscore light 299792458. These constants represent values that may be used in various parts of your program. In your main Python file, you can import the required constants using the from statement. For instance, from constants import pi, speed underscore light makes these constants readily available in your main.py file. This modular approach improves code readability and maintainability. By keeping constants separate, you avoid duplication and ensure that changes to a constant's value are reflected throughout the program. Additionally, it aligns with Python's philosophy of simplicity and clarity, making your code easier to understand and work with. This practice is especially beneficial in collaborative projects where multiple developers are working on the same code base. Immutability in Python. In Python, constants are typically created using naming conventions, but the language itself does not enforce immutability for these variables. This means that even though you may define a variable as a constant, there is nothing stopping someone from reassigning its value later in the program. However, for stricter definitions of constants, Python provides tools like the enum module and the final type from the typing library. Using typing.Final, you can explicitly indicate that a variable should not be reassigned. For instance, you can define pi as a constant with pi final 3.14159. This makes it clear to both developers and certain type checkers that pi is intended to remain constant. If someone attempts to reassign pi, static type checkers like mypi will flag an error, although Python itself will not prevent the reassignment during runtime. This approach is especially useful in larger projects where maintaining the integrity of constants is critical. By using final, you add an extra layer of clarity and discipline to your code, ensuring that constants remain unaltered. While Python doesn't provide built-in immutability enforcement, these tools help developers write more robust and predictable programs by aligning with the principle of treating constants as unchangeable entities. Practice example. Using constants in a program helps make the code more readable, reusable, and easy to manage. Let's write a simple Python program to calculate the circumference of a circle by using a constant for the mathematical value of pi. The formula for the circumference of a circle is 2p radius, where p is approximately 3.14159. Instead of hard-coding this value into the formula, we define it as a constant for clarity and ease of modification. The program begins by defining pi 3.14159 as a constant. Next, it prompts the user to enter the radius of the circle using the input function, converting the input to a floating point number for accurate calculations. The program then calculates the circumference by multiplying the constant pi and the radius provided by the user. Finally, the result is displayed using a formatted string for better readability. This approach demonstrates the importance of using constants for fixed values like pi. By doing so, the code becomes more understandable, and any future adjustments to the constant, such as using a more precise value, can be made in one place without altering the main logic. This practice not only improves code quality but also aligns with Python's emphasis on readability and simplicity. Key takeaways: constants in Python are special variables that represent fixed values intended to remain unchanged throughout the execution of a program. While Python doesn't enforce immutability for constants, following certain conventions can ensure clarity and consistency in your code. The most common practice is to use uppercase letters with underscores to separate words such as pi 3.14159 or max underscore limit 100. This naming style makes it immediately clear to developers that these variables are constants. In larger projects, it's a good idea to define constants in external files or modules. This keeps your codebase organized and ensures that changes to a constant's value only need to be made in one location. Additionally, for stricter control over constants, you can use tools like typing.Final, which prevents reassignment of the constant when used with static type checkers. These practices make your code more predictable, maintainable, and easier for others to understand. Well, by treating constants as unchangeable entities and adhering to these best practices, you align with Python's philosophy of writing clear and readable code. This not only reduces errors but also helps maintain the integrity of your program over time. And that's a wrap on our discussion about constants in Python. We've covered what constants are, how to define them, and why they're important for maintaining clarity and consistency in your code. Remember to follow best practices like using uppercase names and consider tools like Final for stricter constant definitions. If you found this video helpful, don't forget to like, share, and subscribe to stay updated with more Python tutorials. Thank you for watching, and I'll see you in the next video. Happy coding!